Welcome to NaOH Academy. It's your teacher, Dennis Obongi. Today we shall be looking at nucleophilic substitution reactions of halogenoalkanes. First of all, you're supposed to know what is a halogenoalkane. So, a halogenoalkane. What is a halogenoalkane? We have the word here, halogen. And then somewhere here we are having alkane. Alkanes have a general formula of CNH 2N plus 2. If we have N to be equal to 1, 2, 3, 4, and so forth, let us substitute N with 1. We shall have CH4, or which the name of this alkane is methane. If then you substitute N with 2, you're going to be having C2H, 2 times 2, that is 4, plus 2, that is 6. So you have C2H6. The name of your alkane is going to be ethane. So you realize also we have the suffix ane in all our two alkanes. Now, how does the concept of a halogenoalkane come in? You should also know the meaning of a halogen. Halogens are elements of group 17. That is chlorine, chlorine, bromine, iodine. All those ones there are halogens, elements of group 17. Now, if you take an alkane and then you remove one hydrogen from the alkane and then you replace with any of these halogens, the compound that is formed is now called a halogenoalkane. So, take for example, in methane, where we have C4, CH4, and then you remove one hydrogen and you replace with, for example, chlorine, you will now have CH3Cl, which is chloromethane. So this one here we name as chloromethane. If you have ethane, C2H6, and then you remove one hydrogen and replace with bromine, what will you form? C2H5Br. Our compound here is the bromomethane. Chloromethane, bromomethane. This one here, we are having a halogenoalkane with one carbon atom. Here, we are having a halogenoalkane with 2 carbon atoms. So, a halogenoalkane is a combination now of the alkane and then a halogen. So, this is how we get a halogenoalkane. Today, we are looking at the reactions, nucleophilic reactions of the halogenoalkanes. First reaction with aqueous sodium hydroxide. If you hit a halogenoalkane with aqueous sodium hydroxide, what do you get? Take for example, chloroethane, CH2 or Cl, and then you heat with sodium hydroxide. Our product here for this substitution is ethanol. We have the OH from the alkali replacing the chlorine from the halogenoalkane. That is a substitution that takes place in this reaction. That is one substitution with it when you have the reaction of the halogenoalkane with the sodium hydroxide solution. The second one is when you react a halogenoalkane with the cyanide ions. With cyanide ions, that is in ethanol. What happened? Take for example, you have CH3, CH2, Br, and then you react with the cyanide ions. What do you get? Here, the Br in the halogenoalkane is going to be substituted with the cyanide ion. So you get CH, CH3, CH2, Ca plus what? Here we have the bromide ions. Even here we shall form sodium chloride in that reaction. So this is a nucleophilic substitution. This one here is a nucleophile, the electron-rich species. In the sodium hydroxide, our electron-rich species is the hydroxyl ion, the one that donates the lone pair of electrons. Third nucleophilic reaction of nucleophilic substitution reaction of the halogenoalkane is with the ammonia. That is with ammonia. That is to say NH3. Also in ethanol. So when you have a halogenoalkane, again take for example CH3, CH2, Br reacting with the ammonia in ethanol. What do we form? We form CH3, CH2, N, and H2 plus HBr. So you are having here amino ethane, the product of nucleophilic substitution reaction of this halogenoalkane, which is bromoethane. This one here summarizes our nucleophilic substitution reactions of halogenoalkane. The first one is with the aqueous sodium hydroxide solution, and then the second nucleophilic substitution reaction is with the cyanide ions, and you form that one. The third one is with the ammonia in ethanol. And what you form? The ammonia is substituting bromine, and you get amino ethane. Thank you for watching this video. Like, comment, subscribe, be blessed.